Hey guys, Justin Howell with J. Howell Custom Home Builder. We're back here at our Sunflower Hill project. We've got the basement foundation in and the floor over top of that. We're now working through the excavation on the main house and garage. I'm here with Martin Chenoweth, and we're just taking a look around, looking what's going on. Martin's going to talk a little bit more about what we're seeing in the field here and some of our construction practices. Martin, tell us a little about what we're seeing here in the background, what we're seeing for our different soil piles, and then maybe we'll go back and take a look at what's going on with excavation.
Okay. This side, we've got a layer of what's called the Walker Field pediment that's on top. It's this reddish material, which is actually landslide material off the book cliffs. And that gives us a little isolation from the shale, but with this basement construction, we're going to be down. The foundation is actually would be on the shale. So the shale in this area is just slightly expansive. So what we're doing is we're going to get it wet so that it does its swelling, and then we compact it. And then should it get wet again, it will only swell up to where it is now.
So Martin, let's maybe take a look around here at what we've got going on with excavation. So now we've come around from the front driveway. We're in the central portion of the house, right in the great room, inside the excavation, right in the great room nearest to the entryway. And what we're down here to see and take a look at is we're going to show a little bit about how we do the testing of backfill in our different lifts.
This is the process shale.
This is the process shale.
And this is where he's moisture conditioned it to where it takes the swell out of it. So you can tell by the color of it, it's got good moisture in it.
Okay.
And then just to verify that, I've got the moisture density gauge.
Yeah.
And it gives us what the actual number is.
So Martin, what specifically are you doing right now?
Okay, we're making a hole for the probe for this gauge. On this gauge, there's a small piece of radioactive cesium on the end of the probe, and then the box is essentially like a Geiger counter, and it counts how much radiation makes it back to the gauge. The denser the soil, the less radiation makes it back, and this has the capability to tell us how many pounds per cubic foot the density is and what the moisture content is. So just stick this down the hole. Hit go. Wait 15 seconds and give us the answer.
So while we're waiting for that, basically what we're doing right now is we're bringing back this processed shell. So we've put moisture into it so it's at the right moisture content, or it's, I guess rather, Mr. Scoggins has done that. That's who's doing the excavation. So we're bringing that shell, which is a native material, back in. Basically, we've conditioned it and put it back in our terms, like Martin had mentioned, at a compaction that fits his design. This is the second lift of that you see here, this darker material. It's a little bit wet, which makes it compact really well.
Yeah, that's one of the keys to getting compaction is having the right moisture. And there's what's called the standard Proctor test, where I take a sample of this and pound it with a given compaction rate, and then weigh get the moisture and the density, and then I'll take another sample of it, add more water, and we'll get this curve. And when you get what's called the optimum moisture, and or the maximum dry density and the optimum moisture, and that's what's called the standard Proctor. And here, this varies a little because if we have a little rock in it, then the density will go up and the moisture will be down. But here we're at 15.7% moisture, which is really good. They'll
do this in various locations and at various lifts. And it's just basically to make sure that we're keeping up with the overall design, that we're actually constructing this in such a way that meets Martin's design. And then also, we at the end of that, we'll wrap that in with the structural engineer too, because they design the foundation around those parameters, bearing capacity and all of that. So it's just cheap insurance. As you can tell, there's a lot of information here. There's a lot that goes into this process and these designs, and the difference between a quality built home and just an average home. Thanks for joining us today. I hope you got something out of this and it was informative for you. Please like and subscribe. It really helps us out. Share this with your friends. We're just here trying to educate, share our knowledge and what we do in our processes of building custom homes. So join us next time, and thanks for joining us today.